Hello everyone. I think it's 12 and we will be starting it right now in time. So thank you very much. Thanks for joining us today for the ASME B31.3-2020 Code Changes webinar. My name is Omar Faruqi and I am the Business Development Manager at Northern Crescent. I welcome you all today. We have a great audience today and I'm excited by the richness of experience that you all bring. And we look forward to have an engaging event today. But before we start, I want to go over a few housekeeping items. Firstly, there is a question and answer session box on the left side of your screen, the window. You can ask questions at any time during the presentation. This window is moderated and there may be a delay in seeing your questions in the main window. Secondly, the recording of this webinar will be available to all participants and we will send an email link by early next week. And lastly, we are hosting the webinar using Microsoft Team Live. So there are some limitations in this platform. So please bear with us for any technical challenges that we may face. Now, benefiting from the rich audience today, I request you all for a short poll and would be happy to share the consolidated results during the presentation. So let's see what matters to you and what would you like to have as the single biggest capability in the engineering firm of 2021 and beyond. We have dropped a link in the chat box, so kindly take a minute to pick your top #1 choice that you would like to see in the engineering company in 2021. The poll question says, what is the most important consideration for you to hire in an engineering company in 2021? Number 1, cost reimbursement model. Number 2, cost fixed price model. 3, quality of engineering work products. 4, process automation for quality, HSE, and engineering workflows, or AI and other emerging technologies like drone, etc. So we'll give a minute to everyone to pick their choice, and then we'll share the poll results. Okay, I think we are gathering the results. So, let's move on, and then we will share the slides once the results are compiled. Now, before jumping into today's topic, I want to give you an overview of who we are and what we do, so that you may relate better to why we have chosen today's topic. Founded in 2010 in Calgary, we are a team of specialty engineers, and our portfolio spans across a range of industries and facility types. By discipline, we are segmented into pipeline engineering, facilities engineering, integrity and fitness for service, regulatory and compliance services, and integrated project management solutions. And by capability, we deliver from small MOC projects to large greenfield projects. Furthermore, our geographic footprint maps onto 3 continents now. Outside Canada, we have serviced our clients in the US, Latin America, China, South Korea, and parts of the Middle East. Consequently, our engineers are always referencing several engineering and regulatory codes, including ASME B31.3, and we always get opportunities to review and compare several details. Now, as a company, we have delivered over 300 major engineering projects, and we maintain a full-time team of professional engineers in our office locations in Calgary and Grand Prairie. And it's not only about the volume of work we have delivered, it's about the quality too. Our QHSE track record has been flawless. We never had a design failure or any employee incident in office or the field, and we are really proud of that. Lastly, I want to, we want ourselves to progress by being part of the new and emerging trends. Despite external industry pressures, we kept our focus on R&D and continuous improvement. And I'm again proud to highlight that we have registered over 350K spent on R&D projects alone during the last 2 years. For an engineering firm of our size, this is a significant commitment. And also, our service excellence rests on the 3 pillars of our differentiation. With our team of hand-picked professional engineers, we incubate diversity, and having a good balance of experience across our teams helps us harvest innovation and drive efficiency and continuous improvement for our clients. Our people participate in industry platforms, represent in engineering code committees, and are engaged with the universities on several R&D and innovation related projects. And finally, our professional team also comprises of software engineers that are helping us to develop innovative tools to drive performance efficiency and cost optimization for our clients. I encourage you all to please visit our website for further details and welcome you to reach out to us for any queries. With this, I now hand over to Adil Raza to talk us through what to expect in ASME B31.3-2020 release. Adil is the president of Northern Crescent and is a recognized industry leader with over 15 years of experience. He has been part of high impact engineering projects in Canada and overseas. Adil is also a member of ASME B31.3 Code Committee since 2011. Over to you, Adil. Thank you.
Well, thanks very much, Umar, and thanks everyone for joining today in this webinar. We are having a little bit of a handover difficulty, but if I'm hoping that now everyone is able to see the slide and myself. So thanks everyone for coming and for this webinar. We are going to do a quick brief code overview. And we are going to look, how the B31.3 is structured, what other B31.3 codes B31.3 is referring or intending to refer in future. And with that, we are also going to do a quick review of responsibilities in terms of who is responsible for what when we are wanting to assure code of compliance. And then we are also, one of those responsibilities is designating the fluid service. We are going to briefly look into that, and then we are going to look how the code works in practice. Just a quick example. And we are going to then, switch over to the B31.3 changes, and we are going to look at the substantial changes in the base code. There are some changes in other parts of the code as well, such as high pressure piping. We are just going to briefly mention those, but we are not going to go in details. So with that, I'm just going to, look at the 40,000 feet picture and say, well, how B31.3 fits into a facility design in Alberta, BC, or Saskatchewan. So in Canada, we have acts and regulations that form the basis of everything that we do in Canada, and you are more, well aware of that. So through the regulations, such as pressure equipment safety regulation in Alberta, refers to a CSA B51, which then refers to a B31.3. And that's where B31.3 gets its legal status. So any facility that is designed and built in Alberta and Canada overall has to be compliant with B31.3 because the regulation requirements are somewhat similar across all provinces and territories. On top of B31.3, the companies can have their own flavor or preferred practices, and that can be covered in a company specifications. If there is a large project, you can do a project specification as well. Now, mostly the code, if you are looking at B31.3, is designed for different designed around different category or fluid service categories. And I'm going to just kind of go through the middle of it, and it will probably help understand better the requirements. Those requirements basically, for example, high pressure, high purity piping, that is a piping system that is requiring significantly better level of cleaning than a regular piping system. And that will really require then specialized manufacturing techniques, examination and inspection techniques. And that is mostly a piping that is used in hospitals or food and beverage industries or pharmaceutical industry. Then there is high pressure piping, and that high pressure piping systems are primarily the piping systems which are more than 2500 pressure class or greater. Category M is the lethal service. The category D and elevated temperature services are a variation of a normal service. So if the service is a very low risk and low hazard, those services are designated as category D, and those are mostly utility air and utility water services where the risk of injury to humans is negligible. Another type of a normal service is the elevated temperature service, and that is where the metals are exposed to a temperature which are beyond the critical temperatures for creep. So 400 degrees C, for example, for carbon steel is where you will start applying elevated temperature services. And then anything that is not fitting into any of these categories will go into the normal fluid service, and that more or less will represent about 60 to 80% of what we are dealing with is normal fluid service. There are very few services that will fall in category M. There are very few services that will fall in category D, and so on. So majority of those requirements which are applicable to the normal fluid service and the category D and elevated temperature services, they're kind of lumped together and they're put into the base code. If we're kind of looking the other way, we can look at in a way with the way the code is written. So everything that is on chapter 1 to 6, that is the base code, and that involves everything from definitions to the design, and design will cover the piping design, the components design, the joints design, and the stress analysis. Similarly, the chapter 3 will cover the materials, which is mostly for impact testing requirements, and try to avoid any brittle failure so that the material fails in a ductile way, so that there is a warning for people to kind of look at it and make sure that there is no imminent, if there is an imminent failure, they can do something about it. At least they're able to shut down the piping systems. Then there is standard for piping components, and those are fairly, this is a fairly short section of the code. It's just a list of the fabrication and manufacturing standards that are referred into B31.3 and are determined to have a consistent design basis with B31.3. So you can use these components without doing much more calculations or rating verifications. Then there are fabrication, assembly, and erection requirements that are mostly covering welding, post-weld heat treatment, preheat, and any other fabrication-related activities. Then the chapter 6 covers the NDE requirements, how you're going to do different examinations, what is the qualification of the person who should be doing the examination, and different type of testing, whether it's pressure, hydro test, pneumatic test, or initial service test. And there are other tests too. And then any appendices that has been referred in these chapters will form part of the base code. And these chapters from 1 to 6 will cover you most of the services, which are category D, normal service, and elevated temperature service. Now, B31.3 is not written like complete sections for each fluid service in their entirety, and that causes somewhat complexity, and that's what this picture is trying to explain. So the chapter 1 to 6 are pretty much a coherent set of instructions which are complete, and you don't have to maybe go to other service conditions to understand the full requirements for the base code. I mean, these are the basic common requirements. Now, if you want to design maybe say a category M or a lethal service piping, you will basically go to a M300 series code paragraphs. Say for pressure testing, that will be M345. So the way B31.3 is written, it is layered system. So you will go to M345. M345 will basically build onto what you see in 345 series. And that way you can then determine what are the fuller requirements for category M service. So it can modify the base code requirements, it can override completely the base code requirements, or it can just say that all base code requirements apply and there is no additional consideration. And you can do the same for all the other services. You can do for high pressure piping, high purity piping, you can do non-metallic. So most of the time you have just two layers, whatever maybe another specialized service condition is or a material is, and then you have the base code. But in some cases, you can have a high purity, high pressure piping. You may have a 3-layer of abstraction. So you may have to go into a high purity, high pressure part, which is part of the high purity systems. But then you have to look at those. Then you have to look at the high pressure parts, and then you have to look at the base code parts. Now, moving on to the other codes that you need to be aware of as part of complying to B31.3 are B31P, which is mostly for heat treatments, B31T, which is mostly for impact test requirements. Again, you want to avoid the brittle failure of the piping systems. You want to give everyone enough time to react to a warning. You don't want to have an impact on a piping and it cracks straight away and there are personnel standing beside it and we have fatalities. Now, B31E is a slightly dated standard, but hasn't really made into B31.3 yet. That's mostly around seismic design for above ground piping systems. B31J is primarily covering all aspects now, all the inputs that we really need to do in stress analysis softwares for stress intensification factors and flexibility factors for components such as T's and other, say, weldolets. Those are all covered in B31J. And then there are some newer non-metallic piping systems, piping codes such as B31, NM1, NM2, and NM3. And those they cover everything that B31 3 chapter 7 covers. But these codes are much more detailed than B31.3 chapter 7 right now. And in due course, you may see that they may be referred in B31.3 in next code revision or so, and then eventually replace B31.3 chapter 7 in further revisions. So the two green codes are changed in B31 in 2020. So B31P is added as a nice to have kind of requirements. So you can either use B31.3 code provisions for preheat and post-weld heat treatment, or you can use B31P. B31P is just more detailed. I mean, they go much more focus into how the heat treatment needs to be done, some more conditions around those, even going down to the detail of even thermocouples, how those have to be employed. And B31J was a nice to have requirement in 2018 version of B31.3, but now it's a mandatory requirement. And this is one of the biggest changes in 2020 code, that now you have to calculate your inputs for your stress analysis for simulating these components using B31J. You can't do it the old way in 2018, the way we used to do it and using Appendix D. Appendix D is now deleted. So I think I just want to give maybe, who is who in B31.3 code compliance. So designer is responsible for designing everything that is code compliant. But it is owner's responsibility, the responsibility that it has to be code compliant. One other thing that owner is responsible for is determining the design requirements, construction, examination, inspection, and testing requirements. Now, there are two ways you can look at it. You can either have your corporate specifications that cover entirety of B31.3 and then build on top of that, and that will become now the requirement for design, construction, examination, and testing requirements. Or the second way is that there are 8 locations where in the base code, B31.3 says with the owner's approval you can do that. Right, and those, whether you grant it or deny it, that also sets the code requirement for that project or facility. One other thing that is, where the owner's responsibility comes in is fluid service designation for anything other than normal service. So if you give it to a designer will design that system to a normal fluid service, unless you say, well, no, I want to look that as a category D or design it as a category D or a category M, high pressure, high purity. So that is all comes to the owner, that how they want to design their systems. And similarly, if you want to implement a quality system with the designer and say, well, the designer has to meet this ISO 9000 standard or 9001 standard, that is owner's responsibility to enforce that. There are 2 folks for which the qualifications are given. If you have ever doubt that whether my designer is qualified or my owner inspector is qualified, both of those qualifications, exactly what is the bare minimum qualifications, are they are given in B31.3, and they're more or less, I mean, for designer, they're more or less aligned with PEng, but they're slightly more than PEng. I mean, in terms of requirements of experience with the code. So looking a little bit into that fluid service category categorization requirement. So this is a very simple and I think comprehensive chart that is given for designating different fluid services. This is an Appendix M of B31.3, and you really have to go, left to right, go through different columns. The more nodes you have, most likely you will have a very low consequence piping system, and you will, with falling on the right side of the responses, you will end up with a category D, which is the lowest hazard possible category in in B31.3. There's the normal fluid service. Those are basically everything that we do in oil and gas. That's what we design to normal fluid service. That and if you don't have a toxic service, or you do have a toxic service, and the normal fluid service cannot provide enough protection, then you can end up with the lethal service, and then you have to do a much more detailed analysis, and your inspections and inspection techniques will be much more stringent. Similarly, if you're just high pressure and nothing else is untowards in the piping system, then you are going to do a Chapter 9 design, which is high pressure piping system design, and that is mostly more than 2500 class. Or if you are even in 2500 class, but you want to say, well, I want to design a 12-inch piping, which you won't be able to find a pipe thickness. ASME section Chapter 9 rules are I think the allowable stresses are relaxed, so you can use maybe commercially available thicknesses in those sizes, but I haven't come across that case yet. There is one category that code does not provide any requirements, and those are high pressure and lethal service. There is no code requirements given right now in the code, and that's considered outside the code service, but chances of having that service is very low. Now, looking at, if we assume that, somebody is just opening up an operating company and they want to do a new project, this is what kind of tells them how B31.3 drives the conversation around, requirements for different things, whether they are looking for a piping class, why the piping classes are needed and why stress analysis is needed, why corporate specifications are needed. That's, you can see from this overall map, that where you will start is there are 2 things. You're probably going to start with a fluid service because you know that maybe I have an emulsion in my facility that I will be processing, or a gas, And you will probably have an idea about, what kind of material you're going to use, whether you're going to use carbon steel or stainless steels and those kind of things. And those are going to drive the conversation. You know the fluid surface, you put it in a piping class. Similarly, you know the material, you can do then the calculations for pipe, and then you can select the wall thickness. Again, you can put it through the to the piping class. And similarly, you will have different fittings. You will have either fittings that really take the rating from your pipe wall thickness. That is your T's, your elbows, your reducers. And if they are made to a B169, which is listed in table 326.1, it's a listed component now, and you can just put it in your piping class. Similarly, you can have other things, whether you have fittings with rating, which could be a valve or a flange. If it's listed, you can just put it in a piping class, and you can have other fittings. For example, you can have maybe a miter band. You can have maybe a closure or maybe a specialty flange. There are some requirements given in paragraph 304.2 to 6. If it falls in that, you can just design to it. As long as it's a listed material, you can just put it in piping class. And just, like you come across a fitting that is not here and you are all kind of ending up into this table, you will become an unlisted component. And then in that case, you really have like 4 choices. Either that is a fitting that you have used, you have good QA/QC documents available from another facility, you have that, you can use it, as is, as long as the pressure conditions and design conditions are the same. The other scenario is that you do a burst test. If that's a cheaper option to do, you do the burst test, you divide by 4. That roughly gives you a nice kind of rating for all B31 codes, regardless of the safety factors in each code. And basically that will give you a rating of rating. Or you can do finite element analysis, all kind of a desktop study, or you can do a finite element analysis, using, an experimental, feedback loop as well, so that, you're doing some experiments and some tests, FEA, and that's mostly for a very complicated fittings, I would think. Once you have done all those checks, and these you can give it to a designer. Designer will attest that he has done all the calculations, and then he can put a fitting specification. You can get even a CRN based on that, and then you can either use it as part of piping class or you can use it as a separate component. The chapter 2, paragraph 319.3.20 will drive your stress analysis things. Again, if this is your first, as an owner, first facility, most likely the designer will be doing everything from scratch, whether it's visual or computer based. He will do some sort of stress analysis to comply with the code. Now, if you are doing just copy paste facilities, there could be a case where you say, well, I don't need to do the analysis if there is 0 change, but you have to make sure that there's 0 change. There are a couple of other things that you have to think about it, like especially then when you come to the fabrication and inspection. The high level things, like temperature and durations for preheat and post-well heat treatment, you can just put it in the piping classes. Similarly, the extent and type of NDE you want to do on that piping system, you can just put it in piping class. And similar to that is your NDE and pressure testing requirements. You can all put those in piping class. Now, these are fairly involved part of the code. There are some really good directions that are given in this part of the code for doing actual fabrication, actual testing. And some places, if you're just starting off, those are good enough as long as your purchase order says, meet B31.3 requirements. I think you are starting from a very good point. Now, if you have been doing these projects many times, maybe you start developing your corporate preferences, then it's much better to have a corporate specification. Now, with that, I think that probably gives you a good idea about where B31.3 comes in. It's driven by acts and regulations in the province. We need to use it. And once you are there, you can basically think that, you may not be doing day-to-day code calculations. Once you have these 4 or 5 documents, it gives you enough basis to then develop drawings and documents on a project basis, and you're good to go and you are all compliant. Now, if any of these things is out of date, then I will request you to have a look at that and say, well, if any of these requires updating, because maybe the last time we did it, the piping class was 2010, and now there may be some significant changes between then and now. So with that, we will move into the B31.3-2020 changes. The first thing is, again, related to the listed and unlisted components, things that we were talking about. So listed in any, I think, context, whether it's materials or components or valves, listed would mean that there is a standard listed for it, whether it's a material standard or a design standard listed in B31.3. It has a consistent basis with B31.3. If it's an unlisted component, that means that the design basis is not given in the code, and these are unlisted valves. Just for completeness, I have given here all the list of the valves that are already listed in the B31.3. So B1634, API 6G, 600, 602, 608, 609. These are most likely to be the valves that you will be using. If you're using instrumentation valve, maybe MSSSP 105. And what really the change is that before there was a provision that you have a valve, it looks like a B1634 valve. You can basically use one of the methods that's given in B1634 and basically determine the pressure rating, because at the end of the day, the owner, the designer, is just looking for, what is this valve good at for a certain temperature, right? So if you're going to 100 degrees C, you want to know how good the rating of the valve is. It good for 200 psi or 2000 psi? And that is now, I think, overridden. And the reason is, some of the valves, the designs may not fully fall in B1634, and B1634 methods, when they were given B1634, they were given with the context of following all the other requirements of B1634, right? And with this clause, people were able to use those methods without fully meeting B1634. So now what the impact is that non-standard valves, you have to probably look at them. So instrumentation valves, whether it's a hand valve, needle valve, you just have to make sure they are either following MSSSP 105. If they're not following that, then you just talk to the vendor and say, well, do you have a design basis for that? And it will again go into that chapter that we were looking for, paragraph like 4.7, which it's you do a burst out, you have to do an FVA, those kind of things, and they will have some documentation to prove the rating of the valve. So you can do that. And again, if your piping system, especially upstream mining side, if you use a lot of plug valves, pinch valves, knife gate valves, those are again standards which are not directly related. Written in the code. So those ones, again, you want to have a conversation with your suppliers to make sure that they have a basis that is not invalidated by removal of B1634 methods going forward. And if they don't have, then we should get all that documentation to make sure that the valve is actually rated alternatively as well. Moving on to the other significant change, that is SIFs and flexibility factors. So right now, B31.3 has Appendix D, and whenever we do stress analysis, in stress analysis, you will think about, modeling a pipe. You model that pipe, and it's a cylindrical shape. It's simple, but when it comes to branches and other fittings, the simple models like Caesar and Autopipe needs to know exactly how to deal with them. And these are, you can think about imaginary numbers like SIFs and flexibility factors are imaginary number that represent a stress intensification of a component as compared to a pipe. Like how quickly it will fail if you are putting the same pressure and temperature on the pipe versus that fitting. If it fails much quicker, then you're going to say, well, this is failing 3 times quicker. So you're going to give a number which is probably 3, right? And similarly, there, in order to correct like maybe too much over conservatism, you have flexibility factors where, these T's, for example, they have a certain flexibility. They may not stay rigid, like right in the middle. They will most likely be flexing when you put the loading on that. So those flexibility factors then modify your rigid behavior of the piping system by a certain flexibility. So with these two combinations, you are able to accurately predict how the piping systems is going to be behaving in a stress model. So the stress model is representative of your real life piping systems. So the main issue here is that This SIFs that B31.3 has were done by Markel back in 1940s and 50s. Then Rotoba also kind of did some work later on, but those are like 1950s kind of numbers and calculation methods that we have in Appendix D. And those methods now basically B31.3 is saying that we have, and I mean, this project has been going on from 2006. There is an STL project that was done. Tony Paul and his group developed SIFs and that were published in B31J back in 2017. And those one were included in B31.3 as a nice to, I mean, you can use that kind of a provision, but now it is, you can't use Appendix D anymore, right? And that is, I think, recognition of things that on some of the larger diameter sizes, large diameter small branches, and again some thickness combinations, the Appendix D is not conservative. It actually is quite liberal. Now, that does not mean that we need to dig everything out of the grave and start validating all the previous piping systems that are done. It just that, because B31.3 has a factor of safety on 3 on the tensile strength of a material in most cases, then I mean, if you are off on your SIF and you're off by SIF by a factor of 2, 3, I think you are getting very close to the failure. But if you're off by a factor of 2, you're still not going to see a failure. So, and I think I will probably go on a side here. When somebody says that you are not code compliant, it does not mean that the piping is going to fail tomorrow. Right, so it only means that the safety factor on that piping system is not the same as code intended, and there are ways you can do fitness for service and all the other detailed analysis to make sure that the piping is structurally sound to do whatever work it's doing. But code compliance failure does not mean, I mean, you don't want to have a non-code compliant piping from the day one. I mean, you really want to have a code compliant piping from the day one. And if it over time it does not remain code compliant, you can do a fitness for service. But having said that, highly recommended that you use from, I think tomorrow your PO is going out, you include B31J, because legally speaking, I think B31.3 is going to come out somewhere in May if there is no other publisher delay. I mean, by the end of the year, we will have maybe a B30. There is enough time out there that apps start enforcing B31.3 to be as part of the code, and if as part of the design. So 2020. So I think what we really need to do is we need to kind of start taking a proactive approach and say, well, if the POs are going out tomorrow, and especially if there are longer projects, maybe delivery in 2020, design completion in 2022, it may be a good idea to maybe add that requirement here. The other, I think this is the most significant change, impact test requirements for valves. So there has been some background discussions going on around whether the impact test requirements for A106, A105 are adequate or not adequate, and there is, from a printed book point of view, there is no change. I mean, but how you were using in 2018, you're using A106, A106, A105 type materials, curve B materials in the same way. Where the things have changed is before, when you were, your design temperature was warmer than the minimum temperature in the code, and whether it's a straight temperature given in table A1 or it was given in a curve in figure 323.2.2, you will be able to then use the filler material and weld material. You do not need an impact test of that if the temperature was colder than -29. And the only exceptions there was that if your consumable that you are using is already impact tested. So if your consumable is not impact tested, the one that you are using for maybe welding A106, now the limit is -18, sorry. And because the limit is -18, there is a good chance that you may need to do an additional PQR on that welding procedure to ensure that like -29 design stays. So you are not going to do an impact test on -18. That's the limit. You're going to do it whatever your design minimum temperature is. And most of the piping classes right now, for regular temperature in Alberta, are designed for -29. They're not designed for -18. So if you want to not change your piping classes and you want to keep those because they have been working well for you, then basically you need to change your you need to change your maybe you need to add, not change completely, but you need to add a PQR in your welding procedure that qualifies that welding procedure for -29 if the filler metal that is being used is not already impact tested by their AWS specification. The other one is, again, related to the PQR. This is actually the other way around. Like, this has made it much more streamlined. So in the table 323.2.2, there was number of tests for the fabricated welds, and those number of tests were, or you can say the field welds. Those number of tests were, I mean, the requirement for how many test specimen you need through thickness. Those were different than ASME Section 9. So you could have a PQR that is done to ASME Section 9, but they may need yet more test coupons to qualify the same weld thickness that you're qualifying in ASME Section 9 for weld thickness. You may need more specimen for that. And, like, I mean, it was felt that ASME Section 9 requirements were more than adequate for impact testing too, like as they are for the weld thickness. So, I mean, we can use ASME Section 9 thickness, and it took some time, but eventually we got there, and now now they are the same. Like, now, if you are doing a B31.3 welding procedure, compliant to B31.3, you just need to follow ASME Section 9 requirements for weld thickness coupon and an impact thickness coupon. So they're much more streamlined. So it's going to improve, I would say. I mean, if it was being missed, now it's not a concern, but if it was being done, now it's probably going to do some savings. Another, I think it's a finer detail kind of a change. Again, it kind of is a difference between what this figure, a socket weld flange versus a socket weld fitting requirement, minimum code requirements were. So in 2018, it used to say typical details for figure 328.5.2b. And it used to say minimum welding dimensions for socket welds. And both values are different. This is 1.09 of a nominal wall. This is 1.4 of the nominal wall. Now, that has caused some confusion that the actual minimum requirement, code requirements are these. And if you do it, like, I mean, this is just a typical detail. And if you do this weld of the same dimension as this, then this weld is okay. So now the code has taken a more clear approach or clearer approach, and basically what they have said is these are, I mean, this is also now reading as a minimum welding dimensions for double welded slip-on and socket weld flanges. And again, if you have borrowed this requirement from B31.3 into your corporate specification, you may need to review. We need to review those. Other than that, like, I mean, if your corporate standard for fillet welds is already 6 millimeter and it meets both of them or not, or thicker, and it already meets those, then we are good. I mean, we are going to be we are not going to making any changes. There are, again, nice to have changes at this point in time, not a mandatory changes, and those are regarding preheating of post-weld heat treatments. And now, again, as I alluded, there is a B31.3, B31P standard for heat treatments available. You can use that. It is very detailed for preheat and post-weld heat treatment requirements. In terms of real changes for P1 materials, not much, but it is just a good guide. If you were lacking some details around fabrication and preheating and post weld heating and generally around welding requirements, this document is a much more detailed and direct document. Again, if you want to incorporate those into your corporate welding procedures, you can do that. Couple of other changes. These are not base code requirements, so there is a significant change around high pressure piping code section of the code, and basically some of the allowables for some of the materials have gone from 0.67 to 0.8 of SMYS, and that's just to make them consistent with ASME Section 8 Div 3. Similarly, the fatigue requirements have been simplified. There were two requirements. I mean, SNN, there are two methods that were given in code in 2018 and before. SNN approach, which is stress versus number of cycles, just a curve, and the other is a fraction mechanics one. You could use either or. At that time, it was just felt that, you know, SNN approach is good enough if you can if you can show and ensure that there is a leak before burst mode for this piping system, and if it is, you can use a simpler approach and you don't need to worry about the fraction mechanics. Now, let's look at some of the no changes. Their design basis in base code hasn't changed. A design equation hasn't changed. With stresses for the P1 materials mostly used in upstream hasn't changed. Testing requirement for pressure test hasn't changed. Post-well heat treatment requirements haven't changed. And there hasn't been really no impact test changes, requirement changes to A106 and A105. And so far, I think we are in a no change category. So that really kind of, if we are looking at what does this all means for you standpoint, then basically there is going to be minimum changes expected for your piping classes. If you verified those to 2018, you have a documented, you know, proof that everything was done, checked, and so you can just maybe add another memo and say, well, you know, no changes. You may need to, again, you know, review your corporate welding specifications to ensure, you know, alignment, whether it's PQR, whether it's, you know, like weld testing for the PQR for minus 18 degrees C. Those may need to be looked at in 2021, at least this year, because the code is really hasn't come out, and it will take some time to, you know, get up to speed. I would say that in your purchase order, you start using B31J. It's not a cost adder. It will save you. I mean, all B31.3 compliant or the softwares that show compliance to B31.3 already has this incorporated in them. So Caesar, AutoPipe already have these requirements inbuilt in them right now. You can just tell them use B31J, don't use Appendix D, it's going out. So if there is a design project that is going to be ending in 2022, it will save you some grief if somebody start doing some audits and stuff like that. So similarly, if you have a service specific or not standard valves used being in your piping systems, you can just make sure with those valve manufacturers that their ratings are not determined using the B31.3 2018 provisions for unlisted valves. And if they were using that, then you need to really get the updated documentation to make sure that you have the basis to use those valves for that rating. With that, I have come to the end of this webinar. Now we go to the webinar poll that we had. At that time, we had about 21 responses. There is an overwhelmingly, you know, everyone has voted in terms of quality of engineering work products. Definitely, that's I think it really drives. I think point home that if you have a quality engineering work product, I think it leads to less changes in construction and in later stages of the project, and you know that will probably drive the cost efficiency as well to the overall project as well. So no, thanks very much. Thanks very much for everyone for your time, and I will now take the questions.
I am sorry, I was on mute, guys. Can you hear me now? Yeah. So thank you very much, Adil. It was a good overview. So I'll go through the questions. There are a few questions, and if there are further questions, please continue to drop them in the box. We'll try our best to answer all of these questions. So the first question is that is ASME B31.3 enforced by PESR in Alberta today, and did EPSA approve the 2020 edition for the use in Alberta?
So short answer is right now 2018 is in force, and that's what we should be designing to. 2020 is expected, if there are no further hiccups, 2020 edition is going to come in May 2021. Typically, APSA gives you 6 months to get up to speed, and I think before they'll start looking into compliance issues with the piping classes and all the other documentations, I expect that to be early 2022. So right now it's 2018.
Okay. So, a related question, do you expect APSA to honor the CRNs for the valves until they expire, or we will have to resubmit the new CRNs?
So I think from a CRN validation point of view, CRN will be valid because typically they're on a 5-year or a 10-year cycle. So they will at some point come into renewal process, and I believe at that point APSA will take a much stronger approach to enforcing the new rules around unlisted valves. However, I would say that I think if you have the opportunity to review your valves in next 2 years or so, and then talk to your manufacturers and get the documentation in place, I think it will give you a better better position to have a discussion with APSA if APSA start maybe coming to you for asking some of the questions.
Okay, can you please provide a high-level detail of the code changes impacts on the process piping for service? For severe service.
For severe service. So okay. Severe service requirements haven't changed. So the severe service is really not is not really a service category. There are only 6 service categories. Severe service is a condition that is under can be under normal piping service, normal fluid service. That could be under high pressure piping. That could be under category M service as well. Each code has their own provisions for severe service. They deal with severe service as a condition, and those haven't changed. Now, if you are having design issues with severe service, and not all severe service basically code deals with, I think you should look at Appendix F, precautionary measures in B31.3, and there it allows you to kind of have a more detailed background as to what the code position is with respect to the severe service. So, I mean, the idea is to eliminate severe service in design. I mean, if you can eliminate it, then you have to, like, if you are really concerned about low cycle, high frequency kind of vibration in your piping system, that should be eliminated by design. And there are ways to do it. And if you have other concerns where you have a high cycle, low frequency situation, there are provisions in the code that you can use around your fabrication processes.
All right. Next question is that what about MSS SP 135 and MSS SP 81? Are they impacted?
No, they're not impacted.
Okay. So this next question is on MD-MT change from 29 to 18. So technically, we do not need to change the piping classes, just need to change the WPS use or maybe produce another PQRs. Can you please confirm?
Correct. So just if you are using so maybe there is no change required. Maybe you're using your contractor is using a filler metal that is already impact tested for welding, say A106, A105 type materials, or other non-impact tested materials. So if it already comes impact tested, then you really don't need to do it. You just have reviewed it, make sure that everything works, and you don't need to change your piping class as well. I think where the question will become is, because you're welding a non-impact test material, there is more likelihood that the filler metal that you're using was a non-impact tested. So the only thing that you need to do is add another PQR to the WPS that shows an impact test at the design minimum temperature that is consistent with your piping classes, and then you're all covered.
Okay, so there are no further questions right now, but everyone is welcome to, if there are any further questions, follow-up questions, please drop us a note. You're welcome to do that. I really appreciate and thank you for your time. Secondly, we will do our best to continue with similar events and similar webinars going forward. So please stay tuned. And if there are any suggestions that you want for us to work on, we are happy to hear back from you and try to incorporate as much as we can in our future events. Thank you. Thank you very much.
Thanks.